Let's talk about another definition we should be familiar with when we talk about sets, the cardinality. For a finite set, the cardinality simply is the number of elements in the set. We do not deal with the sets with infinite elements, and when you go to infinity, the cardinality takes a whole different form. So for the time being, for the finite sets, it's simply the number of elements in the given set. Let's look at some examples. The cardinality of this set, we have A, B, C, D, E, and F, 6 elements. So the cardinality simply is 6. Here's the notation we use to represent cardinality of a set, N of A. N within parentheses the set we want to look at the cardinality of. So N within parentheses you can put any set, B, C, D, or any other label you're using. So here are two examples. The set A is equal to 1, 3, 4. The cardinality of A is N of A is equal to 3. The second one is the empty set. Cardinality for a finite set, remember, is the number of elements in the set. Question is, how many elements are there in the empty set? It's empty. Number of elements is 0. So the cardinality is 0. Let's talk about subsets of a given set. We call B is a subset of A. Make sure you know the order of things we're discussing. B is the subset of A if every element in B are also in A. The notation is B is a subset of A is given here. And here's an example. The first set contains the elements A, B, and D. And the claim is a subset of the set containing A, B, C, D, and E. We can say that what's in red are exactly the elements in the first set. Therefore, this is a true statement. By the way, this is a claim. We are saying something. We are making a statement. So it could be true, could be false. So in this case, it's a true statement because every element in the first set are also in the second set. Here's another example. 1, 2, 4, 7. Claim is a subset of 1, 2, 3, 4, 5, 6. 1 is in the second set, so that's fine. So is 2, so is 4. But the problem is 7 is not in the second set. So the claim that 1, 2, 4, 7 is a subset of 1 through 6 is false. So that's not true. It's a wrong claim, wrong statement. Remember, 7 was the one which got us into trouble because 7 is the missing element in the second set. So to say that it's not a subset, you have to have an element which is not in the second set. So let's look at an interesting example. Empty set. The claim is it's a subset of the given set 1, 2, 3, 4, 5. So if we compare it with the previous example, question is, are there any elements in the empty set which violates what we need? In other words, are there any elements in the first set but not in the second set? Obviously, the first set is the empty set. There are no elements in it. Therefore, no such element which violates like in the previous example. So we have to claim that it's true. As a rule of thumb, empty set is a subset of any given set. Empty set is a subset of itself as well. Here's another interesting example. PQRS is a subset of PQRS. Question is, does it satisfy the definition? In mathematics, whenever we have a definition, we go by the definition. We do not make any judgmental calls or anything. We just see if it fits into the definition. In this case, question is, are all the elements in the first set also in the second set? The answer is yes. Therefore, it's true. Remember, any given set is a subset of itself. If you have the same set, one is a subset of the other. If you look at the first example here and the last example we discussed, There's a difference. Both are subsets. ABD is a subset of ABCDE, and also PQRS is a subset of the set containing PQRS. So both are true, but in the last case, it's the same set. While it's still a subset, we want to distinguish between the first example and the last example. And we come to the definition of proper subsets. Definition is B is a proper subset of A if, first of all, B has to be a subset of A, and A cannot be equal to B. So in our case, the only way it can happen is A has more examples. Going back to previous example, in the first case, ABD is a proper subset of ABCDE, but PQRS is not a proper subset of PQRS, because in this case they happen to be the same set. So let's look at another remark I want to make is the only time a subset is not a proper subset is when they are the same set. So here's an example. ABC is a subset of ABCDE, and let's discuss whether it's a proper subset as well. The answer is yes. ABC is also a proper subset because while first one is a subset of the second one, they are also not equal to each other. So that's also true. Let's look at this example. ABCD subset of ABCD. True, because every element in the first set also is in the second set. Is this true? ABCD is a proper subset of ABCD. The answer is false. The reason is, while it's a subset, they happen to be the same set. Therefore, it's not a proper subset. Let's talk about how to give the negation of all these statements. Remember, A is an element of the set A is a statement. How do I say A is not an element of A? We just simply write a line crossing the symbol for belongs to say A is not an element of A. Similarly, I can say P is not a subset of Q. And I can also use the same thing. P is not a proper subset of Q. So all these things we can negate the statement by crossing the line, drawing a line to cross the symbol to say it is not.